using IK and look at setting up a rig, but also integrate a dynamic element in it as well. What we aren't going to do today is to do the animation of the head. So what happens with the bacteriophage when it has the long neck and within sort of a piercing apparatus, and the nature of the neck is such that when it twists, it shrinks down the neck, pulls the head down that's filled with the genetic material, and that pushes the needle into, or the injecting apparatus into the cell. And so that's actually an interesting thing to try and model too. But let's look at just doing the first setup here. And what I'd also like to do that I don't normally do when I do a modeling thing like this is, if we have time, set it up to latch onto a surface and follow a deforming surface using follicles. We looked at the rivet tool before. Remember that rivet script that attaches locators onto a deforming surface or any surface? We're going to look at doing the same thing but using follicles this time. So we're going to use hair in two different ways. Okay, so if you want to, you can follow along and do this. I'd like you to try and build this at some point today. It's not that hard to build, really. But we're just going to start making a joint system, and it's got, I think it's got 6 legs going around, so that's the way we're going to build it here. And just like any other time, when you're building a rig, you always want to start in the middle of the world. Or sorry, in the middle of the world and in one of the orthographic views. So we're just going to use the joint tool here and just use the standard setup. We don't need to change anything about the tool. The only thing to consider is the direction that the orientation of the joint will be. So the joints are always going to be pointing down the x-axis, and we want to preserve that. And the reason is when a joint rotates, you want to be able to predict the way it's going to rotate. And if you have linked joint systems that are rotating about different axes, then you'll get unpredictable rotation. So the standard setup is fine here. So we're just going to build out in the middle of the world, and we're going to start sort of from the root here, and I'm going to use the X key to snap, just so we can get everything nice and clean from the beginning. And then go up one. So this is the root joint. This will be the root joint of our thing, and this is kind of like its hip joint here. And then go down to the knee, then to the ankle, and then we're going to make a little toe like this. So we can have a shape, something like this. This is a little, actually looking at it now, maybe I'm in too close to the middle of the world. So if you want to move joints around, you can select the joint and just move them, and the children will also move. It will start to mess up the rotation axis of the one above it, or you can hit D on the keyboard and just move that joint, and then the children won't move. So you're moving it like a pivot point. So I'm just going to pull this one out a little bit. I'm going to hold down X again, grab this axis, and just pull the knee out a little bit. Then I'm going to do the same thing with these other two joints. Just maybe move them over. One. Okay, hit D again to get out of that. It used to be, D is a new thing, and a fairly new thing in Maya. You used to have to hit the home key to go, and you can still do that. And on the keyboard on a laptop, it's more confusing. It's function left arrow to do that in case D key doesn't work. But if you see tutorials asking you to go into pivot mode, pivot point movement mode, sometimes you can hit function left arrow or insert or home on your keyboard, but D should work. So if we look here in the perspective view, and please stop me if you want me to go over anything because I'm just looking at my screen mostly here. So we've got this thing, it's lined up in this axis on the X plane here. And instead of rebuilding this, we're just going to duplicate it and rotate it about the center of the world. But before I do that, I want to clean things up a little bit. So if I select the parent joint here, you can see that the rotation of this one is sort of off now. It's not quite matching exactly, pointing down towards the next joint. So if I select the parent here and then go into the skeleton menu set and go to Orient Joints, this allows us to go back to those initial settings. So remember, the primary axis was X, and the secondary axis and world orientation were Y. That was the same as our initial setup. And if we click this with this one selected, it's going to change the orientation of the child, of each child of this root joint here. So I'll supply this, and then you see this one pops and is pointing straight down the axis of the next, towards the next joint now.
Mark, how do you select individual joints, like without selecting the children?
Well, you know what? I'm not sure, because I am selecting the children here, but it probably shows up on yours as if they're all green.
Yeah.
Yeah, I don't know why mine is doing that. It just started doing that, so I'm not sure why, but it should be fine. That's kind of what you want to have happen anyway. If you select a high-level joint, all the children should also be selected. Now, saying that, sometimes you want to select the children without selecting the parent. Let's say we don't want to select this root joint. Then you start from the bottom, and then you hold down Shift and work your way up. And here we'll have these 4 selected without the parent selected, which is sometimes necessary. So if we look in the outliner here and just twirl open the joints, if I hold down Shift, it opens up the whole hierarchy here. And I press on the X. And so I've got joint 1, 2, 3, 4. So I can rename these if I want. So you'll notice up here in the status line, this is a generally useful tool, but if you want to rename a whole bunch of things or select something by its name, you can use this window up here. You can also select something, give it an absolute transform or a relative transform. So if you want to move it somewhere particular, you can type those XYZ values in here. You can select by name, but we want to rename these. So instead of joint, we want to call these leg A, let's say. And hit return, and see it renames all of these leg A, 1, 2, 3, 4. I'm actually going to change this to leg joint, JT. So if you don't see that up here, you might see this little, does everybody see this thing on their screen? You can change by clicking on this little drop-down menu what the field does with the information you type in there. So we just want to put a rename. I just put a leg underscore JT underscore A. Sorry. When I'm on HDMI mode, the screen resolution gets very fine. So I just click on this, and now it's renamed all these things. Yeah.
When I did it, just rename the top one.
Did you have them all selected? So select them all in the outliner. That way, just select the top level one, then Shift select the bottom, and it will make sure everything is selected in there. Okay. So now we want to duplicate this leg a bunch of times around this center pivot point. But if I try to do that, we might run into some problems here. So I'm selected and actually I should rename this top level one. This shouldn't be called leg A, this should be a root joint. So I can just change that one on its own, because we're going to attach all the other legs to this one. They'll be called leg B, whatever, whatever, whatever. So if I just select this top level joint and go to Edit and Duplicate Special, I can try to rotate about that center point and make duplicates. So if I make copies, and if I rotate around the y-axis, 60 degrees and I make 5 copies. Duplicate special. I'll get this kind of weird thing happening here. It's rotating around a weird axis. If I just undo, it looks like my y-axis is straight up and down right now, but that's my world y. So that's the axis of y in the world. But remember this joint is pointing down the x-axis, which means y is actually pointing up this way. So that's kind of a pain. So probably the easiest way to fix this is just to do a quick workaround. And I can unparent these things from the root joint. So I can just select leg A1. It will select all its children too. Well, it will select it. And its children will go with it. And if I just middle mouse drag it outside of that group, now I've got this thing disconnected from this. So this sits as its own thing. Now I can't just do a duplicate special again because the pivot point's in the wrong spot. If I do it, it rotates about this thing's pivot point, right? So what we're going to do is just quick workaround. We'll just group this thing with itself. So if we select this upper level node and just hit Command G, I've grouped it so you can see here in the outliner what's happened. It's just put that node under an empty transform node, which is called group 1. But the benefit is that group 1 has nice clean orientation. It's centered at the middle of the world. Y is pointing up. And now I can do the duplicate special on the group. And it does a nice little rotation for me. Does that make sense? What we're doing there? Yeah.
So when I duplicate special, I can't put the geometry type to instance.
So you don't want it to be instance. It should be copy, yeah.
But I can't, for some reason, G-translate rotate parameters are longer.
Okay, so let's just look at my setup here. So if I just reset this, then I want to make copies, because for this sort of thing you don't use instances because they don't have shape nodes or transform nodes. They have transform nodes but no shape nodes. And we're going to group under parent, and here now you should be able to change these values.
Yeah, I just had to reset the settings.
Yeah, it could be that it was under. Yeah, I don't know what your settings were at, but anyway. So if you reset and make sure it's on copy. And then you should have something like this.
So sorry, how did you get it to rotate in
Oh, sorry, yeah. So if we go back to duplicate special. So remember that it's X, Y, and Z in these columns. So this middle one is Y. So we want to rotate about the Y axis. So 0 and X, 0 and Z, and 60 degrees. So this is in degrees, not radians or anything like that. It's in 60 degrees, and then if we make 5 copies, it will rotate, make a copy, rotate, make a copy, rotate, make a copy, and so on. And then we still have the original, so that would be our 6th one. Yeah?
Mine rotates somewhere else. So
Did you group the original one with itself?
yes, I did. But it doesn't rotate around me.
So maybe because you're in the
Okay, just undo what we did there. Okay, so you have the group selected. You've got a -8 and translate there.
Sorry. It must have been default.
Yeah, that's okay. So try that again. There you go. Are you tweeting how awesome the class is? Thank you. I appreciate that. Makes me feel really good. Okay, so here we are. So now we've got all these things grouped together, but we don't want them grouped. So if we just select all these groups, we can just go to Edit and Ungroup. And then those groups disappear and we're left with our legs. Now they're not really named properly anymore, so we'll just have to go through and rename them because they're all named leg joint A, but we want to do B, C, D, and E, and so on. So we can just take a second to do that. So just the same thing, I'm going to select this leg, all of the joints in here, top one, shift select the bottom one, and then I'll go up to this rename thing and just change it to B. Same thing here, change this one to C. D. And I'm sure you all know by now you can't leave spaces in any names in Maya, right? So that's why I'm always using underscores. In one of the interviews I got to talk about Iowa. I said, what am I supposed to say? Beat Iowa? Beat? Yeah, I said it and it worked. They were impressed.
It worked.
I think it was your roommate, your guest.
Yeah, I guess.
I'm leaving on Friday. I had to go buy the t-shirts for the kids when I'm there. So the thing to remember about a joint system is that it's just a visual representation of a hierarchy. It's nothing else, but with transform nodes. But a visual representation of them, how they're going to rotate and things like that. We're going to use these to parent things to or to skin things to. So we'll look at the difference between skinning and parenting. Skinning and parenting a little later on. Brittany, we were looking at that with 2 ways of doing the spine, things like that. So this will be relevant to that too. So I'm just going to close all these up. And the thing with doing these joint systems is you want to try and keep it as clean as possible, things named properly, just because it can get kind of out of hand trying to organize what's what as you go along. Oh, it's kind of, I did these all out of order, so I'm missing some. I'm going to change these names manually. Now you could name these a little even more sensibly. You could call this leg A hip, leg A knee, leg A foot, and then leg A toe. But I'm not going to bother doing that. So because these are just a visual representation of a hierarchical system, if I want to rejoin these sort of subjoint systems to the root, all I have to do is to drag the top level node onto the root with the middle mouse button in the outliner. And it will make a connection for me. So you see this new joint connection is made when I do that. Just want to select, if I inadvertently select all the joints in leg B and drag them onto the root, each one will make a connection to the root. And you'll get something screwy like this. So you just want to select the top level, so in this case the hip of leg B, and drag it onto root joint using the middle mouse button. Now some of you may encounter the frustrating middle mouse thing. If you open up your settings, I can never remember where this is. It's probably UI interface. Oh yeah, so under the settings, under preferences, under interface, you can tell Maya what kind of mouse you're using, 1, 2, or 3 button mouse, but you can also disable the scroll wheel. There's not really much use for the scroll wheel. Some people tend to use it for zooming in and out, but that's you can use the right mouse button for that. But if you don't disable it, sometimes you'll accidentally zoom when you're trying the middle mouse button, things like that. So I generally will have that turned off. And then I'll just carry on selecting the top level node, dragging it onto the root of each of these legs, using the middle mouse button. So now we have them all connected again. So this root joint is going to have kind of, it's not going to be pointing down a particular axis. It's actually probably going to be pointing down the one you first attached it to. I'm not sure, but it can't really have a predictable rotation because it's pointing in so many directions to attach to its children. But that's fine. This isn't one that we would really rotate anyway. This is just a root level joint that the spine of this thing will attach to plus the legs. Okay, are we all good? I'm going to sip the coffee.
There was a place that changed the size of the joints. Where was that?
That's a good question. So, depending on how big your scene is, sometimes the joints may appear too big or too small. And there's a global setting for that under Display. And this is one of the standard menus that doesn't change with whatever module you're in. And if you go down to Animation, Joint Size, you can just turn that up or down. And it will just change all the joints in your scene. So in this case, I actually probably want them to be a bit skinnier. So let me just take a moment to create a project. I didn't do that at the beginning. So where should I put this? Somewhere sensible. I'll put it in my Dropbox. This class is called MSC something something. I don't really need anything here except for maybe a renders folder if I want to make a little animation, and a Maya folder to save the actual scene file in. I'm just going to save this before something goes wrong. (2016). Okay. So let's make the spine now before we do any of the rigging of the legs. So again, when I create a new joint system, I want to make sure I'm in an orthographic view. And I'll make a new joint system starting here and then moving up a number of joints. So I will go to Skeleton, Create Joints. And I'll just, again, use my X key to snap maybe every other. Depends how long we want the neck to be. So something like that, maybe one more. Give it a long neck. And I'm going to rename these as well. Let's call these neck joint. So before we do anything else in terms of rigging, I actually want to make a piece of geometry and skin it to the neck and make the head too. And the reason I want to do that is because we're going to use a curve to make this neck dynamic. And once we do that, it's never really going to, well, it's not going to often be back in this perfect position. So when you're setting up a rig, before you do anything that's going to deform the rig from its sort of its rest position, that's when you want to do all your skinning. And you want to do all the skinning only after you're perfectly happy with the setup of the rig. So for this, all I'm going to do is make a cylinder. I'm not going to worry too much about modeling something. If you guys wanted to make this an interesting piece for your portfolios or something, then you can take this rig and spend more time on actually generating some interesting geometry for it. But for now, we're just going to use a cylinder so we can look at rigging and skinning a little bit. So I'll just create a polygon cylinder. Oh, I've got my settings weird here for making a hexagon or something. So this is 1, 2, 3, 4, 5, 6, 7, 8, 10, 11. So I'm going to make the height 11. Oops, 11. And maybe I'll leave it in this sort of hexagonal shape, but I need more subdivisions along the height. So maybe 22 or something, so it can bend into form. So remember, a joint system is a deformer, so you want it to be able to have enough resolution in its shape to be able to deform. Okay, I'm just going to go. So another thing when you're using joints, you can go into form mode to go into wireframe, right? But if you want to stay in shaded mode but still be able to see the joints, in whatever panel you're in, you can go to the panel menu set under shading. You can say X-ray joints. And you can then have it still shaded, but the joints will show up inside. So that's a little too tall. So I'll go to 10. Okay. So now let's make the head. The head is an icosahedron for one of these guys. And let me name this thing first. This is I'll just call this neck. Geo. So when you're working with joint systems and models, you'll often have geometry, joints, IKs, and curves and things as control objects. So it's not a bad idea to come up with a little naming strategy for yourself. So any of these joints, I mean, they appear as joints here, and they're easy to see joints, but I used a JT in each one of those to indicate that it's a joint. For geometry, you might want to name it something like neck and then have geo after, so it's easy to identify in your outline or what's what. And I'm going to delete its history, freeze its transformations. Now we'll make an icosahedron, so it's one of the platonic solids. So if we just go into the create polygon primitives mode, in addition to, well, you've got some platonic solids here like a cube, but you have other platonic solids already set up down here at the bottom. If we open up the option box, we can select an icosahedron. I think it's an icosahedron. These platonic solids are actually good shapes to use too if you want to make a sphere that's non-polar as well, because they're repeating 2D platonics as well. So this is a hedron, so the 2D ones are the polygons that they're made out of. So let's create that. And I can never remember exactly how it is, but it's something like a slightly rotated head like this, and then if you stretch, oh yeah, that's right. So if we just zoom in here a little bit. So here's our icosahedron, and we want these two lines, let me just undo. So it's shaped like this, right? And you see these two diagonal lines here? We kind of want those to be horizontal. So if I select this and hit E to rotate, I can just rotate this about until those are sort of horizontal, and then maybe make the head a little bigger by scaling it. And then it's sort of elongated in the y-axis, the actual anatomy of this thing. So if we just select the vertices here of the top, the kind of cap, And just stretch those up a little bit. You can center its pivot again. Scale. Okay, are we all good with that? That's fine. If I smooth it now, you'll get sort of this sort of thing. We don't really want to smooth this. I'm going to delete its history, freeze its transformations, and I'll name it head and geo. But it's still too perfect a shape. We want to bevel these edges here so it has an edge that can catch the light depending on what kind of shader you put on this thing. Excuse me. So we can just select this and go into wherever bevel is now. So edit mesh. Oh, it's right there, bevel. And when you select the whole object, it's going to bevel every edge. So bevel is just rounding off the edges, right? And I'll just leave it as default and hit bevel. And you'll get something like this. And we just have to increase the segments because you can see it's taken each edge and split it. So there was an edge here before and it's made a new face where the edge was. But we need more segments to round it out. And we might want to change the fraction to make them tighter. So they're not quite so loose. And if it's that tight, then we don't need quite so many segments. So now I don't have to smooth this thing, but if I do smooth it by going to 3 mode, you can see it still doesn't lose its shape. It keeps those beveled edges. So if I put a shader on this, like I'm going to save this because Maya kept crashing the other day whenever I opened up the Mila material. So I'm just going to save this now before I do this. So if I just add a Mila material to this, actually I'm just going to put a blend on this right now for a sec. Yeah?
Could you just repeat how many fractions did you increase it? Did you increase the segment to make it smooth? Or?
I increased the number of segments. That adds divisions,
Okay.
and then the fraction is how widespread they are.
Okay.
Yeah, so tight fraction, a few, I think I put 3 or 4, I don't know. Whatever works. So you can see by beveling how those corners can now catch the light here. So when you have a perfect edge from a primitive object where just 2 faces come together, there's no bevel right there, so there's nothing to catch light on a specular, so it's important to add those bevels. I'm sure you did that when you and Stuart were talking about hard surface modeling and things like that. But this is essentially a hard surface model because it's not going to deform at all. Now you could model this to be more organic looking, I suppose. I don't know, whatever you want, but for now we're just going to stick with something like this. I'm just going to move it down a little bit so it's kind of penetrating the neck a bit. Okay, and delete its history. So once I delete the history, I can't change that bevel anymore. But that's okay, I can live with that. Freeze its transformations. Again, you want your geometry to be all nice and clean before you skin it, or in some way attach it to your joint system so it's going to behave in a way that's predictable. Because you've all seen by this point that Maya can be unpredictable. But once you start to chase down the problem, there's usually a reason for that unpredictability in the creation of different objects. Sometimes it's just frustrating and there's seemingly no reason. But so the first way you can skin something is you can merely just parent it to a joint. So this last joint in our neck chain, we're not going to use it to deform the neck at all, this one joint at the end. So we're just going to use it as a parent for the head. So we can just select the head geo and middlemost drag it onto neck joint 5 in my case. And, oops, I grabbed both things. Oh, and now my crash. I did some bad mousing there. It heard me complaining about my crash. Well, I just saved it a minute ago, so we're good. Okay, so yeah, we're right back here, happily. Just going to move this down a little bit. And let me just go through this stage and then the initial stage of skinning, and we'll take a short break. And make sure everybody's caught up. So the head, I just want to make a child of neck joint 5. So if I just middle mouse on that onto the neck joint, then it will now follow that neck joint. So if I select this and rotate that joint, then the head will just follow. So that's all we want it to do. We don't want this joint system to deform this head. We want it to appear like a solid, rigid cage, but it has to follow the neck around. Save that again. So that's one way you can attach something to a joint system, is simply to parent it to a joint, or to make it a child of a joint. The only tricky part sometimes about parenting something to a joint is that these things are all parented to each other in this hierarchy. So if you wanted to, let's say, make a curve that you could use to move one joint, and if you made it the parent of this joint, then it would, it's like it's adopting it, and this is no longer its parent. So it would break the connection between these things. So sometimes instead of parenting, you can use constraints. So let me just unparent the head from that joint. Instead, I'll do a parent constraint. Ultimately, I'm going to go back just to the regular parent, so you can just leave it, but I just want to show you. So if I select the joint, then shift select the geometry and go to constrain, you can use a parent constraint. I'm going to reset the settings. And a parent constraint will control the translation. It will link the translation of the child to the parent and the rotation in all axes. And I've got maintain offset turned on here, because if I didn't, well, in this case it would probably be fine. Actually, no, it wouldn't. If I turn this off and did this, the head will jump down. The middle of the head will jump down to where the joint is, probably, yeah, because it's linking the pivot points. So that's how it knows what translates to translate values to. So instead, if I turn on maintain offset, it will just remember this distance that they hold between each other. So I just say add, and now under the head geo, there's a new constraint node. And we can see that in the channel box here. And it's got a link to neck joint 5 with a WO of 1. So that's a weight of 1. If I turn that off, then it's not going to follow. So the benefit of using a constraint rather than just simply attaching something in the hierarchy is that a constraint can be turned on and off. And we saw that before when we talked about an object picking up another object when you did throwing the ball with in the exercise we had for that. So that's similar. So I'll just leave this constraint on. It doesn't matter. You can do either way. So now let's look at other method of attaching geometry to a joint system. But before I do that, I'm going to do one last thing with the joint system. I'm going to connect the neck to the root joint here, because you can see they're still not connected yet. So if I grab the neck, not the geometry, sorry, if I grab the neck joint, the high level joint here, so not high in terms of high in the world, but high in terms of top of the hierarchy. If I just middle mouse drag that onto root joint, and it will make that connection in there for me. It's hard to see, but there's a new joint there now. So that just means if I select this root joint and move it, the whole thing moves with it. So if you ever want to move the whole thing, it's the root joint that you're going to select, at least for now. Okay, so let's do the skinning. I'm going to save before I go on any further. So we want to skin the neck geometry to the neck joints. So one thing I'm going to do that is a little different than you might see if you're watching a tutorial, but I don't like to have this joint included in the skin because it's not attached to any other joint. So I treat this like my end joint, and I just want to select all of the other ones. So I don't want to select this one, but I do want to select this joint, and then shift select going up the hierarchy until we get down to here. And we don't want to select the root for this, but just the neck joints. So if we look here, we've got all the neck joints selected except for neck joint 5. And if you did have neck joint 5 selected, it wouldn't be the end of the world, but it might just deform in slightly a weird way because this little joint would just be attached probably to the vertices right at the top here, and it might kind of deform in a strange way. So then we'll shift select the geometry. So you can see I've got the neck geo selected now, and we're going to skin this. So beside the skeleton menu set here, we've got the skin menu set. And to skin it, we have to bind the skin. And let's just open up the attributes for this command. So the different options that we have here are what do we want to bind to. So we don't want to bind to the entire joint hierarchy because remember we're not selecting this one, and it's selected to the legs already and everything. So we want to make sure we change this in this case to selected joints. Now a lot of times you do join to the whole hierarchy, but in this case we're not going to. Everything else, oh actually I have to reset my settings because I think mine are, yeah, I changed mine a little bit. So go to selected joints, you can leave all these other things as they are. And then we've got max influences. So this is how many joints can influence a single vertex. If you want to control this, so only the joint nearest the vertices affects it, you can reduce this down to 1 or something. If you want a smoother overall deformation, so if it's bending, the bend down here will still influence vertices up here slightly. If you have it set to 1, only the joint rotation here will influence the vertices here. So it's how far reaching it is. So in this case, it's not going to really matter too much. In some cases, you might want to really reduce it. So as an example, for Brittany's spine in her skeleton, we've got lots of little joints. And we're doing a skin on these joints as a single object, but we don't want the bending of a joint down here to influence things up here. So I reduced that to max influences of 1. So it's only one joint, the nearest joint affecting the vertices. Well, let's just leave it at the default settings for this one. We'll bind the skin. And so now what should happen is if we rotate one of these joints, then it will deform. Now you can see the bottom level one, when we rotate that, it's just rotating the whole thing. It looks like it's bending a little bit, I can't tell. But this is doing essentially what we need it to do. Yep.
Is it better to use bind skin than the interactive bind skin?
Well, the interactive bind skin puts sort of a capsule around the thing you're binding it to, and it lets you shift that capsule to, if you've got a more complex model, it's a way of just localizing the influence of certain joints on an object. So for doing a whole body, that can work well. For something like this, it's not really necessary.
For myself, would you use interactive or just the bind?
Okay, well what I would do was probably use bind, because I haven't used interactive for doing a body. It's probably better to do it, but I don't know. So you can look at that and try it. But for something like this, what you would end up doing is binding it, and then you can paint the weights. So an interactive bind skin, if we just look at that, let me undo this, I'll get out. And I will select the joints again. Select the geo, and go to interactive bind skin. And so what this does is it creates, you can see it says volume type, it creates a capsule or a cylinder around the joints. So if we bind skin, now you can see each joint, if we select it, will have this capsule around it, and you can control the fall off of the influence of that joint by changing the shape of this capsule, by moving this up and down. So this gives you sort of an immediate way to control how far the influence of this joint is felt. So if I move this one up, now this joint's movement is going to influence a lot more of the geometry. So now if I select this, in this case, I don't know, it's not really showing it. Oh yeah, so you can see what's happening here. Because when I rotate this one, these vertices have a capsule that come all the way up here from this joint, and then they've got a capsule from this joint, and these ones have a capsule from this joint, so they're kind of arguing with each other a little bit. So when you have overlapping capsules, you can get sort of deformations like this. So what we're going to do instead, I'm just going to undo that until that's gone. I'm going to just do the regular bind. Let's make sure everything is set up. And now we can paint the weights. Remember last week we painted the weights of the clusters, the influence of the clusters. In this case we don't really have to paint the weights, but I'll just show you. So if you select the geometry and go to skin and paint skin weights, you can see that it opens up this tool set where on the left side we've got the names of all the joints here, and the influence that they have over the geometry is shown. So if you wanted to, if you don't want this joint to influence so far down here, you could then paint the weight. So you could replace this with a value of 0 here. And if I start painting up here, you can see that we're painting out the white. So if you have a complex model where you're skinning rather than parenting, part of the process is going through and painting the weights. So to make sure that when let's say I have the spine weighted to my whole body, when I twist, I don't want anything weird to happen to the shoulder. I want the weight of the deformation of the shoulder only to be influenced by the shoulder girdle and maybe part of the clavicle, things like that. You want to make sure that the spine doesn't have influence that extends this far out. So you have to paint the weights to do that. In this case, we don't really have to paint the weights because it's just a cylinder. It's just a straight piece of geometry, a straight joint system. So it's not really necessary. can use a color ramp to show going from white is 1, black is 0, but here it's remapped those colors from white to black, from red to blue. So you can, in some cases this might be easier to see. Just different ways to visualize it to make the workflow easier. I'm just going to undo out of that because I don't want that painting I did to be on there. Let me just save again. So why don't we take a break for a few minutes, but just so you know, what we're going to do next, and we'll get done this morning, is rig the neck to be dynamic, so it can sway with movement and with forces in the world. And then we're going to make the IK system for the legs and a reverse foot, so we can walk this thing around, or we can lock it onto the ground so that if the ground is moving, the legs can stay anchored in place to make a dynamic looking sort of animation. Okay, so before we take a break, any questions? Anything? No? You're good. Okay, so yes.
Wait, after you.
Okay, so it's 11:15 or 16 now, so let's start back again in 10 minutes, okay?